housing, there are many criteria that go into the ingredients for what we create. I mean, there are challenges. In affordable housing, we have fixed cost cap financing. And of course, all of you in building know that rising labor and material costs are putting a crunch on actually what we can build. We're not oozing with money. Now, we live in Maine, and we serve the people of Maine and New Hampshire. And our temperatures range from -10 to 90 degrees on an average year, 100 degrees swing. Outside, the humidity ranges from 55%, 95%. And so we have a challenge on the exteriors. But our residents, they know there's a large swing exterior, but on the inside, they want it to never move between 70 and 75. Humidity only between 40 and 60%, nice and cool and dry. Property management wants to make sure that our energy demands are going down and thermal comfort is coming up. Because if they're not, the residents that we serve, nearly 5,000 people, will let them know. And so what goes into this criteria? Is it worth it? In 2018, I was asked that question. And so I took a look back when I first started at Avesta Housing in 2013. And this was one of the first projects that were actually completed. It was a garden-style apartment, small, 25 units. It had all the bells and whistles that people could throw at it. Mechanical thermostats, remote access digital controls, two boiler rooms, solar preheat, efficiency design in the envelope. And when I went to visit the building, this is what I saw. 2 mechanical rooms. And by the way, this is all that could fit in my camera. What you're not seeing are the pumps and drives on the ceiling and all the preheat equipment behind me for 25 apartments. Every time I go into this room, it makes me feel like I'm in a nuclear submarine. And I said, why are we doing this? And in fact, here's one of our challenges. We spent $30,000 in 3 years after our first certificate of occupancy. No one knew how to run the equipment. No one realized that the preheat module wasn't connected to the mini boilers. And so things were breaking and overworking. Our costs, $100 a month per average per resident in just the utilities, about $2.40 a square foot. Let's keep an eye on that. So the next year in 2014, I was asked to renovate a property in Bridgeton, Maine. They had high heat and propane use costs. So what do you think I did? That's right, I kept it simple, clean. 2 boilers for the heat, 1 for the hot water. We had a VRF drives, we had our efficiency drives, and the result, $1.90 a square foot. But here's the real learning moment. From 2014, when we did the renovation, 2015 through 18, we progressively were reducing our fuel expenses. That's a win. The next year, I had another boiler replacement of a large, almost 18,000 square foot building, senior property. There were 48 units. Old boiler, about 20 years old. Did it again, kept it simple. This really showed some great savings. In fact, we had a 23% reduction in fuel consumption year over year. And so we're winning, as I thought. The next year we went to replace the windows. Simple, same building, knew exactly where to go. But what did we see? Opened up a window, rot. Opened up another window, rot. Went to the back of the building, rot. So got panicked. We stopped exactly where we were going and decided we were going to have to make some choices. We found, actually, that the contractor 15 years prior had replaced house wrap with 1-inch rigid foam, a new product at the time that was being introduced, maybe not new, but new to this project, and it wasn't in any of the drawings. But as you can see, The first drawing with this gentleman's photo on the left, he's lifting an entire section of vinyl that wasn't even nailed in. They didn't use the right nails. That's just a small aside. But in the center photo, you're seeing these large gaps. What's that? That means they didn't glue or connect all the rigid, and they didn't tape it. So they didn't do air sealing. So I did what any good project manager would do. I called somebody else. I said, what do I do? Actually, I called Jesse Thompson from Kaplan Thompson Architects. He's my go-to expert in the field. We chatted about it. He said, I've got to find the rot. Let's remove all the rigid. And we did. But the idea, instead of replacing it with rigid, was to replace it with a Henry Blueskin. Because I only had a limited budget. It was either one or the other. And so we went this direction, and my company trusted. Now, of course, I took some liberties when we stitched everything back together. The old building on the left is looking old. Now we've took some architectural design risks, and it looks very nice. But here's the interesting part. Remember, I told you in 2016, we had a 25% reduction because of the boilers. And I was really crossing my fingers on what was going to happen by removing an inch of insulation. And so in the following year, we saved another 5% based on air sealing. And that, ladies and gentlemen, was a paradigm shift for me in my approach to buildings. I mean, yes, I can save fuel by efficient boilers, but I could also save by having a better envelope. And the connection was paramount. So that was the existing buildings up to that time when I was asked the question about how we're doing it. Is it worth it? But what about high performance buildings? How do they operate? I took a little research on 2 key buildings from that year. This is a LEED Platinum building built in Gorham, Maine, 23,000 square feet. Wood frame, electric baseboard, has a solar array, natural gas for the domestic hot water. How did it perform? And I took a look. And as you can see, for a 23,000 square foot building, we used about $23,000 worth of fuel. That's electric and natural gas. That's all inclusive. Lights, corridors, laundry, elevator. Average $70 a month per apartment. 88 cents a square foot. Pretty good. Better than what I was showing you from before. I did another research. This is Bayside Anchor. This was a Kaplan Thompson building. And 45 units, 38,000 square feet. Same thing, wood structure, electric baseboard, solar array, natural gas for the hot water. Results, fairly similar. $70 a month per unit. These are efficiencies, 1, 2, and 3 unit apartments with families. 99 cents a square foot to operate. Not bad. I did further research because we do developments, and HUD requires that we do performance. Our banks require that we do performance when we figure out our operating expenses. This is a 2019 report for HUD's allowances for our units, heating, cooling, cooking, lighting, domestic hot water, refrigerators. As you can see on the left, it shows $142 as an allowance. A 2-bedroom would be $173 per month. So why is that relevant? Because of what I showed you before. In an efficient building, if I can show $70 per unit all in, there's 2 thoughts here. As an affordable housing operator, I can provide an allowance for people, and by building efficiently, I can save that money to put back into operating expenses, things that I'll need, roofs and windows and doors and such. As a private developer, well, you could market yourself as a low-cost operator, a low-cost expense for a resident to live in your building. Now, I've always asked, these are different buildings, and how do we know that we're really saving money if all buildings are not created equal? Well, I'd like to introduce you to the Meadows at Grapevine Run. It's in New Hampshire. The building you're looking at right here was started in 2017. It is a code compliant, nice building, propane heat, hydronic system, 24 units of senior housing, wood structure, so on and so forth. It was a 3-phase project, and we completed this one, again, like you said, at the end of 2017, with the intention of building 2 more buildings. We chose to go passive house for the next 2 buildings. This is what it looks like after the first building was built. In the photo and on the right, you'll see the orientation of the next 2 buildings. And when we started looking at the costs or the differences between a typical building, code compliant, and a passive house, as you can see, insulation in the foundation was up by twice, the insulation in the walls by 50%, insulation in the attics, you get the point, more insulation as a starter. We made sure that our air sealing, our weather barrier, our vapor controls were all in line. As you can see, our soffit detail was built outboard of all of those layers. Some just logical details on how we built this building. We took our original plans for air sealing and redlined them to make sure that we passed our blow-a-door test and our ACH requirements. So, we all know high efficiency is going to cost too much. We were worried about this. So what I did is, for you, in 2016, the building on the left, as you can see as a spreadsheet, was $2.895 million. That's just the building. Get rid of all the soft costs and all the site work. Well, 2 years later, almost to the day, I added up all of the real costs of the building for a passive house design in the same location. Came down to $3.15 million, 8% difference. I factored in the 1.5% cost or rate of inflation, and the delta between the two is 5%. 2 years later. And 2 years later, here's what you have. The building on the left was the first building you saw. It's a code compliant building. The one on the right is a passive house building. And we're just starting to fill them up. There's another building, by the way, on this site that we'll discuss. I'll have numbers for you in another year. You'll have to invite me back when I do the calculations. So with all that said, I needed to answer these questions. Can we prove that high performance buildings are worth it? And is it worth the money? And can we display the findings in dollars and cents and common sense? And so we went back to work. We created a benchmark tool for all of our buildings, our operational functions of all of the buildings that we had. I narrowed it down to 17 buildings that were built over a 15-year period, all double corridor buildings that didn't matter if they were senior, family, housing first. It just meant I needed to keep same-like buildings. None of these here are renovated buildings, all brand new construction. I want you to see that we saved it in the year that it was received the certificate of occupancy, so 2005, 2017, the type, number of units, the square footage, the BTUs per unit, square foot, so on and so forth, and categorized each building by design. High performance had some components to it, obviously passive house certified, LEED certified, so on and so forth. Now, I want you to keep your eye on the property names. Just look at that list. I'm going to click, and you notice how the names change. Now you go to the yellow line where it's million BTUs per square foot. And then you look at the building design all the way to the right. And what happens? All the code compliance, they go to the bottom. All the high performance, LEED, Passive House, they go to the top. And on average, you look right in the middle, these numbers per square foot of energy are 100% less than the code compliant buildings. Okay, go back to the properties. Fix your eyes on those because they're going to change as I click out. Buildings are going to move around. Now we went to total operating cost per unit. What things changed, but what happened? Most of the code compliant buildings still stayed on the bottom of the database. And the high performance, sure, things are going to move around up and down based on size, based on number of units, but code stays in the bottom. High performance came to the top. 100 and same average. About here you are at $800 a unit versus $1,200. So maybe you're at 50% cost savings. That's real money, by the way, in operating. Now I want you to look at it one more time. Properties, they change again. I go back to the right. This is total operating cost per square foot. Same thing happened again. I didn't even try to make this happen. All the code compliant buildings stayed at the bottom. All the high efficiency buildings stayed at the top. Here's the biggest thing that we realized. I'm saving real money per square foot when I'm building a high efficiency building. So if I can borrow $200,000 to go from a code compliant building in New Hampshire to a passive house building, I'm reducing my per square foot cost per square foot per year over a code compliant building. Now, that allows me to reduce my operating expenses. But also, what I'm trying to use this formula for is to be able to introduce more solar to our buildings. But it allows me to show Maine Housing, New Hampshire Housing, you all in this global network, that high performance buildings, they do work. And they do show that they pay. So for Avesta, what we realized is that, you know what, a 3 to 5% cost increase, if we can afford it, is worth it. We know that the buildings are going to be more resilient to Mother Nature because of the envelopes that we develop. Residents, well, anyone who's a certified passive house designer, consultant, or even remotely knowledgeable in this arena knows that thermal comfort is the basis of passive house itself. And with 5,000 people, at any time they're comfortable, that means they're not writing the senator or the governor or the congressman about why they're unhappy that they're too cold, too hot, too this or too that. That's good. Now for property management, we can save money in operations. That's important. We have a 99-year commitment to HUD to keep these buildings. Our energy consumption is reduced, and as we build more passive house buildings, our carbon output is getting reduced. That's my message I wanted to share with you, and I've used this information to try to promote passive house as a QAP, which is a qualified application for points to be able to build more buildings to Maine Housing and New Hampshire Housing. And if you have any questions, this is going to be a Q&A. Let's start.